Today I'm going to tell you all about the secant line, the tangent line, the average rate of change, and the instantaneous rate of change, and how they all relate together. To get started, the first thing you need to know about is the secant line. A secant line is a line that goes through 2 points on a graph. Today we're going to start with finding the slope of the secant line, and we're going to take the limit of that secant line, and that is what's going to turn into our tangent line. So if you look at this graph, what you'll see is a secant line going through 2 points. What we want to happen is that second x value, where it says x plus h, we want to get it to where h is heading to 0. So it's getting closer and closer to our initial x value. And let me show you what that's going to look like. Currently we have 2 dots and a secant line going through. But as we get this h value to get closer to 0, meaning it's going to get closer to our first x value, what you're going to notice is, let's say you have a value there, and then again here, and we draw a line through those, and that slope is getting steeper and steeper. If we get it a little closer and put a point here and a point here, that line again is getting closer and closer. And what we want it to do is, what we're looking for is the slope at just this one value. And then you'll have a line that goes through that 1 point. That is the slope at that instant. That is the instantaneous rate of change. We want the slope at that instant, which is going to be your tangent line. But to get there, we're going to start with the slope of the secant. Let me show you how that works. First, we're going to find the slope of the secant. And to do that, we're going to use these x values up here. Now, we don't know what our function is. So that means if this is our x value, then our f of x is our y value. Then at the second point, we have x plus h. And then that y value is f of x plus h. So now we have 2 points, and all we need to do is find the slope. Slope is the change in your y value over the change in your x value. So that slope of the secant line is the change in your x value over the change in your y value. So again, m stands for slope. The slope of that secant line is the change in my y value. So I'm going to use f of x plus h minus f of x. Those are my y values, all over the change in my x values. X plus h minus x. And of course, we're going to simplify. So when we simplify this, we have the slope of the secant line equals f of x plus h minus f of x all over h, right? Because this x minus x, those drop out. So what you need to know is this equation right here, the slope of the secant line, is your average rate of change. This is something you're going to want to write down, put it on your math cheat sheet list, that special piece of paper that you have that has all of your equations and things for quick reference that you need. You need to know that the slope of the secant line is your average rate of change. And the slope of the secant is just finding the slope of any line. But if we go back to our original example, what we want is the instantaneous rate of change at 1 point, at a specific instant. That's what we're looking for. So now how do we take that slope of that secant line and make it our instantaneous rate of change? And I'm going to show you. It's going to be by taking the limit. By having h approach 0, we're going to find it at that instant. So this is what it'll look like. If we take the limit as h goes to 0 of the slope of the secant line, remember m stands for slope, this will equal the slope of the tangent line. Remember, a tangent line goes through a graph at 1 point. That's the instant. So when we took that initial graph and it was going through 2 points and we got it closer and closer, so it was going through 1 point, that is called a tangent line. So if you take the limit of the slope of the secant line, that equals the slope of the tangent, and this equation is written as the limit as h goes to 0, and now I'm plugging in the slope here. So f of x plus h minus f of x all over h. This right here is your instantaneous rate of change. This is the slope of the tangent line. Now you have to know that sometimes this can be written two different ways. So I'm going to show you the other way that this can be written with different x values. Sometimes they use x and x plus h, sometimes they use x0 and x1. So let me show you what the slope of that line will look like and the slope of the tangent line. Depending on which method you want to use, you can use either one and you will get the same answer. If we're finding the slope of the secant line using these points, I'm going to write out our x and y values that we're using. So x sub 0, comma, f of x sub 0, and then x sub 1, f of x sub 1. These would be our two xy values. Now I'm going to go ahead and find the slope. So therefore, your slope of your secant line would be y2, right, your y value minus your other y value, all over your x value minus your other x value. So this again would be known as your average rate of change, the slope of your secant line. Again, same principles, y2 minus y1 over x2 minus x1, that's just the slope, but this is just another way to write it in a general form. Now let me show you how this translates into the instantaneous rate of change and the slope of the tangent. Remember, the slope of the instantaneous rate of change, the slope of the tangent, is just when we take the limit of the slope of the secant. So we're going to take the limit as x sub 1 goes to x sub 0 of the slope of the secant line. And that's what gives you the slope of the tangent, which will be the limit as x sub 1 goes to x sub 0 of x sub 1 minus f of x sub 0 all over x sub 1 minus x sub 0. This right here is going to be that instantaneous rate of change. So here are the main takeaways that you need to know. Make sure that you write this down on a piece of paper that's easy for you to access that you can have out while you're doing your homework problems. The slope of the secant line is your average rate of change. And the way that you solve this problem is just by finding the slope. Now, the slope of your tangent line is your instantaneous rate of change. That means it happens at one specific point. And there are two different equations that you can use to find the instantaneous rate of change. You have the limit as h goes to 0 of f of x plus h minus f of x all over h. Or you can use the limit as x sub 1 goes to x sub 0 of f of x sub 1 minus f of x sub 0 all over x sub 1 minus x sub 0. These are the key points that you need to have written down on a piece of paper to help you remember the difference between the secant line and the tangent line and how to find them. Now let's try some practice problems. This one is just asking for the average rate of change. The average rate of change is just the slope of a secant line, which means it's the slope of 2 points. We have been given a function, so we're going to use those points and go ahead and plug it in. The function that we're using is x cubed. So the first thing I'm going to do is just sketch a quick graph of x cubed. Now I'm going to go ahead and plot the points that they gave us. They gave us x sub 0 is 1 and x sub 1 is 2. So I've got 1 here, 2 here. And now I'm going to go ahead and find the corresponding y values. So if my x value is 1 and I plug that into x cubed, I have a y value at 1. And if my x value is 2, my y value is 8 for x cubed. Now, of course, my graph is not drawn to scale, but this will work. Now all we need to do is find the slope. So our 2 points are 1, 1 and 2, 8. So 8 minus 1 all over 2 minus 1. I'm just finding the slope here. 7 over 1. So our average rate of change for this function is 7. For this problem, they want the instantaneous rate of change at a specific x value. Now remember, the instantaneous rate of change is the slope of the tangent line, which we find by taking the slope of the secant line. So I'm going to go ahead and set up our x and y points so we can set up our slope. So for the first one, we have 1, 1 again. Our second one is going to be x and x cubed. So we want the limit as x is heading to 1 in this problem, or take our y values, find our slope, all over x minus 1. Now, of course, we're going to have to factor that numerator, and hopefully you remember how to factor cubes. If not, I'm going to write it in the thought bubble over here. So if you don't remember how to factor cubes, got to write it over here. When you have a cubed minus b cubed, that equals a minus b times a squared plus ab plus b squared. Now I'm going to rewrite our limit problem. So we have the limit as x goes to 1, and in the numerator, we're going to have x minus 1, x squared plus x plus 1. And all I did was follow our a cubed minus b cubed equation. In the denominator, we have x minus 1, which hopefully you are getting excited, and you can see that these two will go ahead and drop on out. So we're left with the limit as x goes to 1 of x squared plus x plus 1. And now what we can do with that is just plug in our x value. So that equals 1 squared plus 1 plus 1, total of 3. So our instantaneous rate of change for x cubed at 1 is 3. Now we're going to go ahead and try to find the instantaneous rate of change at some general point for x cubed. So first we're going to start with the formula for the instantaneous rate of change, which is the limit as h goes to 0 of f of x plus h minus f of x all over h. So what we need to do now is to go ahead and plug in the function they give us, which is x cubed. So we have the limit as h goes to 0. This function is going to be x plus h cubed, because that's our function, minus x cubed all over h. All right, so now we have this factor on top that has to be cubed. So I'm going to do in a little thought bubble just that part on the top for us. So I'm going to take this piece right here, and in the thought bubble over here, I'm going to multiply that out. So we've got x plus h times x plus h times x plus h. I'm going to leave that first one alone. We're just going to leave x plus h. I'm going to factor out these second two. We've got x squared plus xh plus xh plus h squared. And this in the center will become 2xh. I'm going to open up my thought bubble here a little bit. because now we got to multiply the last part through. So now we have x plus h times x squared plus 2xh plus h squared. This is getting to be a very big thought bubble. So now as we multiply this out, x cubed plus 2x squared h plus xh squared plus x squared h plus 2x h squared, I'm running out of room in my thought bubble, plus h cubed. Woo! That's a lot. I'm going to put this whole line here into my limit. So we've got the limit as h goes to 0, x cubed plus, now we should take, I can take this guy, and we have 3x squared h plus, now my xh squared in that one, so plus 3x h squared plus h cubed, right, minus x cubed. That's this guy coming down because we haven't had him in there yet. All over h. Whew. Anybody tired yet? This is a lot. Okay, now I'm going to go through and cancel some stuff. X cubed minus x cubed go ahead and drops. And what we have left, I'm going to pull an h out of. So the limit as h goes to 0, and I'm pulling that out so he can eventually cancel with my denominator in the bottom. And here I'm left with 3x squared plus, here we have, I'm sorry, h comes out, 3xh plus h squared. So hallelujah, our h's are going to drop, and we're going to be left with the limit as h goes to 0 of 3x squared plus 3xh plus h squared. Well, when we go ahead and we plug zeros in for our h value, this is 0 and this is 0, so our answer for this limit is 3x squared. This is your instantaneous rate of change. Now let's say you wanted to find the instantaneous rate of change using the other formula with x sub 0 and x sub 1. I'm going to show that to you now. So the first thing you want to do is set up your x, y pairs so you can set up your slope. So we have x sub 0 comma f of x sub 0. And we have x sub 1, f of x sub 1. And we do have a function. So this guy right here can be written as x sub 0 and x sub 0 cubed because this is the function we're plugging in. And this pair is written as x sub 1 comma x sub 1 cubed. So now we have two xy pairs that we can put into our limit slope problem to find the instantaneous rate of change. So we have the limit as x sub 1 heads to x sub 0. Our y values, x sub 1 cubed minus x sub 0 cubed, all over x sub 1 minus x sub 0. And lo and behold, if you don't remember your thought bubble, we have two cubes. So when you have a cubed minus b cubed, that breaks into a minus b times a squared plus ab plus b squared. So that is what we're going to need to plug into our numerator. So we have the limit as x1 goes to x0 of x sub 1 minus x sub 0 And then you have x sub 1 squared plus x sub 1 times x sub 0 plus x sub 0 squared all over x sub 1 minus x sub 0, which you should be excited about because, of course, those will drop and be a 1. And then you are left with the limit as x sub 1 goes to x sub 0 of x sub 1 squared plus x sub 1, x sub 0 plus x sub 0 squared. Now all we have to do is take our x sub 1 and plug in x sub 0. So every time you see x sub 1, you're going to plug in, so this guy is going to become x sub 0 squared plus x sub 0 times x sub 0 plus x sub 0 squared. So this guy right here is just x sub 0 squared. So you have 1, 2, 3, x sub 0 squared, so x sub 0 squared, which is the same answer that you got when we did it with the limit as h goes to 0. So again, you can choose either way, you don't have to do both, but this is an example of how you can use the limit as h goes to 0 and the limit as x sub 1 heads to x sub 0.